Hi everyone, my name is Rajiv Das. I am from the Department of Mechanical Engineering, Techpur University. In this presentation, I will explain the modeling and analysis of one-dimensional transient heat conduction using the implicit BTCS method in MATLAB. The objective of this assignment is to numerically solve the one-dimensional transient heat conduction equation with a fixed temperature boundary condition at one end and an insulated boundary condition at the other end. I will also explain the MATLAB implementation stability of the method and the temperature distribution obtained at different times. So, here is the introduction to the physical problem. The physical system considered here is a one-dimensional rod. Initially, the entire rod is at 0 degrees Celsius. The left end of the rod is maintained at a constant temperature of 100 degrees Celsius. The right end is insulated, meaning no heat transfer occurs through the boundary. As time progresses, heat enters from the left side and diffuses through the rod. Governing equation. So as we all know, the governing equation for one-dimensional transient heat conduction is where you can see in the formula T is temperature, small t is time, x is the spatial coordinate and alpha is thermal diffusivity. Since analytical solutions are difficult for many practical problems, numerical methods are used. BTCS method. In this assignment, the implicit BTCS method is used. BTCS stands for backward time centered space. In this method, backward differentiating is used in the time direction and central differentiating is used in the spatial direction. So the discretized equation becomes, here you can see that. After rearranging a system of algebraic equation is obtained, these equations are solved using matrix method in MATLAB. Fourier number. The Fourier number is an important parameter in transient heat conduction analysis. So it is defined as, here you can see that in this simulation, the Fourier number is calculated automatically in MATLAB. One major advantage of the BTCS method is that it is unconditionally stable. Unlike the explicit FTCS method, there is no restriction on the Fourier method for numerical stability. Now I will explain the boundary conditions used in this problem. So you can see at the left boundary, the temperature is fixed at 100 degrees Celsius. This is called a Dirichlet boundary condition. At the right boundary, the rod is insulated. Therefore, the temperature gradient becomes 0. Here you can see that the temperature gradient becomes 0. That is del T by del X equal to 0. This insulated boundary condition is implemented numerically by assuming the temperature at the last node is equal to the temperature at the previous node. MATLAB implementation. Now I will explain the MATLAB implementation step by step. First, the physical and numerical parameters are defined. These include that rod length, number of spatial nodes, thermal diffusivity, time step and total simulation time. So I will show you the MATLAB parameter section here. Grid generation. Next, the spatial grid is generated using the line space command. The rod is divided into equally spaced nodes. So now I will show you the grid section. Here you can see the grid section. Now after that I will show you the matrix formation. The coefficient matrix for the implicit BTCS method is formed. The interior nodes are discretized using the finite difference formulation. Here you can see it is the matrix formation for MATLAB. So this creates the tridiagonal coefficient matrix required for the implicit scheme. Boundary conditions in MATLAB. Now the boundary conditions are applied. The fixed temperature boundary is implemented using A11 equal to 1. I will show you the code. For the insulated boundary condition, here is the MATLAB code. This ensures zero temperature gradient at the insulated end. Time loop. Next, the transient solution is obtained using a time loop. At each time step, the right hand side vector is formed, the matrix equation is solved, and the temperature distribution is updated. The matrix system is solved using, I will show you here, T nu equal to A slash B. Since this is an implicit method, simultaneous equation must be solved at every time step. Now, result and discussion. Now I will run the MATLAB code here. You can see that the code is running. The command window displays the Fourier number and the stability statement. The graph shows the temperature distribution inside the rod at different times. Initially, the rod temperature is 0 everywhere. As time increases, heat diffuses from the left boundary into the rod. Near the insulated boundary, the temperature gradient gradually becomes flatter, indicating zero transfer through the insulated end. Thus, the numerical results correctly represent one-dimensional transient heat conduction. The implicit BTCS method is unconditionally stable, therefore, larger time steps can be used without causing numerical instability. However, the implicit method requires solving matrix equation at every iteration, making it computationally more expensive than explicit methods. Conclusion. In conclusion, one-dimensional transient heat conduction was successfully modeled and solved using the BTCS method in MATLAB. The fixed temperature and insulated boundary condition were correctly implemented. The temperature distribution at different times was obtained and analyzed successfully. The BTCS method was found to be stable and suitable for transient heat conduction problems. Thank you.